Thank you very much, Asa, and welcome everybody to session Enhancing Mineral Potential with Innovative Exploration Technologies. One thing which is making me curious, why there is more people interested in mine closure than in exploration. But thank you very much for coming, and I'm sure that we will have very interesting presentation demonstrating how exploration could be improved from different perspectives. So, and let me introduce and invite to presentation first speaker. Sorry. Dashamir Gega, specialist representing Department of Mineral Resources of Albania Geological Survey. And topic of presentation is search exploration of lithium in Albania. You're welcome.
Microphone, please.
Okay. In the room, I presentation my theme in Albanian language, but if you have any question, you can make it in English. But it is easy for me to explain in Albanian language.
So, research and exploration of lithium mineral in Albania. The geological studies with regards to the research and exploration of minerals of lithium in Albania started in 2021 from the Albanian Geological Survey, as well as by a private company equipped with research and exploration mining permit in the area of Gjirokastra in 2021. The project undertaken by the Albanian Geological Survey, such as the assessment of precious minerals and also rare earth elements in the Republic of Albania, will continue till the end of 2023 and aims the following: to determine the formational and structural aspects that limit the industrial concentrations of lithium minerals based in the existing data of the conducted surveys in the world and in the region, as well as in surveys in the field during 2021-2022. The comparison of the regional and beyond region of the geological information with the data in the Republic of Albania has been accompanied by a sampling process to be analyzed in the respective labs for other minerals as well as lithium, proposing the potential mining areas for research and exploration of lithium minerals pursuant to the law number 10304 dated 15 July 2019 for private interested companies that will be involved in research and exploration of lithium mineral. The geological documentation with regards to the research of minerals, lithium minerals in Albania. There is a presence of Paleozoic sedimentary rocks in the tectonic areas of Korabi, Mirdita, Gashi, represented by terrigenous deposits such as the black schists intertwined with quartz and sulfur mineralization. These formations ask for an assessment on the presence of lithium minerals and their industrial potential. The existence of Triassic magnetization, represented by the basic medium volcanogenic fascia up to acids that are shown in the area of Korabi, Mirdita, Sukali, Gashi, ask for an assessment on the presence of lithium minerals in these formations. Jurassic magnetization, that is very much widespread in the Mirdita area, represented by ultra-basic, basic, and basic volcanogenic rocks, and that can be seen in the other part of differentiated cross-cutting in granitic areas, ask for an assessment of the presence and potential of lithium mineral bearing of the rare earths. The presence of bauxite deposits in Darda, Funar, in Libraj, as well as in other areas that can be found in southeast of Albania that are mainly related to Cretaceous limestones, karstic pits, is an area that can be assessed on the presence and potential of lithium minerals in Albania. The presence of old clays formed by the alteration of magmatic rocks in the lower Triassic and their redepositing in the medium and upper Triassic limestones in karstic pits in the area of Fush student Peshkopi Kukas asked for an assessment on the presence of lithium minerals and rare earths in Albania. Other factors that are indispensable in the intensification of works of search and exploration for lithium mineral in Albania are to conduct research and exploration works in the Dinarides in Serbia, as well as Hellenides in Greece, that have the same geological development history with the Albanian Albanides. The accompanying of lithium minerals with other minerals such as earth, rare elements, and their exploitation in complex increase their economic interest. The existence of easily exploitable formations such as clay layers and their exploration in open pits and near the national roads increase the interest for a lower cost exploration of the lithium mineral. During 2021 and 2022, under the project undertaken by the Albanian Geological Survey, several surveys have been undertaken and several samples have been taken. And we have mainly samples taken by the black schists, and it has appeared that the lithium content reaches 288.1 grams per ton, cobalt 24 grams per ton, gold 0.5 and silver 1.7. If you can see, there are several objects that have the content of dioxide of lithium that ranges between 264 to 3.3. Seen in complex, there is an increasing interest with regards to this mineral. So with regards to bauxite, during 2021, a survey has been conducted, an assessment has been conducted with regards to bauxite minerals, and it has appeared that the content of lithium in bauxite reaches to 724.6 grams per ton, cobalt is 100 grams per ton, copper 46, silver 0.2, gold 0.2 and silver 2 grams per ton. Seeing this in complex and also the possibility of exploitation of these bauxites for aluminium purposes and complex purposes, these are of a very special interest in order to conduct search and exploration works. During 2021, based on current literature, the subalkaline magmatic rocks have been inspected, especially in the southern part of the ophiolithic massives and also western ophiolithic massives. And we have taken results in the effusive rocks of Guritopit area, which are promising, and works of research and exploration for primary resources of lithium minerals will continue during 2022-2023. Here we have the area of Guritopit, where we have the content of the lithium that of lithium dioxide that is from 522.5 grams per ton, and also silver 2.6 grams per ton. In the Bal area, in the northern part of Albania, in the black schists and also green ones that are on the Triassic carbonatic rocks that are formed by the physical chemical destruction of the upper parts of the ophiolithic massif of Krabi, we have taken samples and we have conducted chemical analysis on the presence of lithium minerals. And it is of a high interest to study this area, and in the photos we can see data where we have taken samples, and the results are as follows. We have 144.1 grams per ton of lithium dioxide and also 2.5 grams per ton of silver in the green schists and also in the black ones from 120 to 1.3. In Ostren-Chopin's area, within the Krasta sub-area flitch, we have a presence of the clay deposits and also clay sheets that have a considerable thickness and several kilometers of extension along the national road of Libraj-Peshkopi. During this period, several samples have been taken and analysis have been conducted according to the following table. We have an assessment of the minerals in this complex, and they are of very much interest to be further analyzed for economic purposes. We have 3 places where samples have been taken, shown in photos. And lithium dioxide reaches to 141.9 grams per ton, cobalt 48, copper 80, gold 1.2, and silver 1 grams per ton. So this is an area that has a potential for further research and exploration works. In the area of Costa Impreval, we have unsaturated conglomerates where the main material is composed from effusive rocks and quartz. These conglomerates that have a considerable distribution in a thickness of 30 linear meters and are reiterated in several cross-cutting parts have a high contact of precious elements and minerals and also lithium minerals. In the photos you can see the formational content and also the results of the analysis. We have lithium 186 grams per ton, cobalt 10 grams per ton, copper 14 grams per ton, gold 3.2, and silver 5. We don't have an analysis for platinum because we cannot analyze platinum here. This year or next year we will take samples for analyzing the platinum group elements, PGE. Conclusions. During the works conducted under the project entitled Assessing Minerals, Precious Minerals and Rare Earth Elements in the Republic of Albania, we have used wide geological material regarding works conducted in our country, as also we have seen the foreign literature with regards to the researches for lithium mineral in neighboring countries and beyond. The results of this analysis conducted during 2021-2022 in our country have provided qualitative and very good indicators for the ongoing works during 2022-2023. Based on the field works during 2021, the sampling and their analysis have determined the petrological and time series horizons where these kind of minerals should be searched for during 2022-2023. The recommendations. So during 2022-2023, we will survey the similar formations to those where vaporized lithiums are extracted, molasses as well, sulfur thermal resources, gypsum clays in the area of Kronj Bistrica, and also in the former mines. We have the area of Drojan, Kardish, Dumre, and Peshkopi. In Peshkopi, we have gypsum clays that are seen in the parts of the Banya as well as the Ravdiv village. The same, we have potential gypsum clays that can be found in Mengai of Kavaya. In Korcha, we will conduct surveys for the content of lithium in Pogradec as well. We have objects that present a considerable amount of lithium in the thermal resources of Peshkopi, Kalesh, Leskovic Brain. Thank you very much.
Very interesting presentation. I'm sure your presentation gave a lot of information for people to start looking for lithium in Albania, and it's very good base to start.
Yeah, I have spoke. We are in the beginning for lithium research, but I have spoke with my colleague. We to take more information from Serbia, from Greece, colleague, to take information. I hope on the future to work together with my colleague.
Yeah. And we wish you good luck in research, and we wish more companies and more researchers come to Albania to start.
Thank you very much.
Thank you. And next presenter, Dragana Savic. Dragana is project manager from Geoin Group, and Dragana will tell us about systematic, multidisciplinary, and proactive approach to solving problems in the field of geology, mining, and environmental protection. You're welcome, Dragana.
Thank you very much. Good afternoon, everyone. My name is Dragana Savic. 2 months ago, when I received an email from Secretariat for MINEX Forum inviting me to present in the sixth and to participate in the sixth MINEX Forum, I thought that it was an opportunity to present part of our experiences in the process of necessary geological research for mining and environmental protection projects with the aim of sustainable mining and exploitation in the countries of Western Balkans. So today I'm very honored to have opportunity to introduce you to the company Geoin Group from Belgrade and our systematic, multidisciplinary and proactive approaches to solving problems in the field of geology, mining and environmental protection. Geoing company was founded in 1996 as one of the first private companies in the Republic of Serbia in the field of geological survey or research. Since 2003, it's been given a new name, Geoing Group, and at this moment we have a business name, Company for Geological and Geotechnical Research, Engineering and Consulting. As you can see on this slide, we have several different services, but the most important is exploratory drilling and service for design and research. Our systematic, multidisciplinary and proactive approaches to solving problems has been recognized by many of our clients in countries in Western Balkans region. Some of our valued clients are Electric Power Industry of Serbia, Bosnia and Herzegovina, North Macedonia, Kosovo Energy Corporation, Belgrade Metro and Train. Our clients for greenfield and brownfield projects are Zlatna Reka Resources, Aerolithium Balkans, Sisa Chemicals, Rakita Exploration, Zijin Mining, Landin Mining, Locus Balkans Metals, and Mine Grot. In the field of environmental protection and renewable energy sources, there are DMT, Eko Tamnava, Crni Vrh, Energoprojekt, and Ivicam. Previous cooperation with the scientific and professional institutes is related to Akita University from Japan, Katin University from Australia, of course, Faculty of Mining and Geology from Serbia, and with the two largest institutes in our country, mining institutes and Institutes of Mining and Metallurgy, BOR. Geoing Group is a member of Geological and Mining Association of Serbia, GRAS. Also is a member of CANSI, a Canadian Serbian Business Association. Our engineers are members of Serbian Geological Society, Serbian Chamber of Engineers, Society of Mining and Geological Engineers, National Body for Quality in Higher Education, and I'm involved in European project, very interesting, NG, which aims to popularize geoscience for girls age 13 to 18. We are aware of our roles and responsibility because geology represents the necessary support for the provision of resources for world's population and industry, provides a spectrum of the most important services and help us understand how we can live more sustainably on our planet, and thanks to our strong skills-based education and research. Our team of experts offer outstanding skills and relevant experience with which can deliver projects on highest standards and at the competitive prices. We have equipment and instruments for conducting investigative works. We take care of ecological protection of soil and groundwater, as well as the protection of human environment. We take care of complaints with environmental regulation and respect for archaeological and cultural sites. Also very important is that Geoing Group adopts the Take 5 professional risk assessment program and begins each shift with the Take 5 for safety meeting. This slide is very interesting. In the exploratory drilling section, in the period from 2060 to May 2022, 2022, we drill about 157,500 meters. That is 75% for the exploration of mineral resources at the surface of the terrain, 14% underground diamond drilling, and 40% for engineer geological drilling. If we look at the percentage ratio of drilling meters of diamond drilling, the most work we carry out for the exploration for the coal deposits, 28%, and for copper, silver, and gold deposits, I think 38%. Also, we prefer engineer geotechnical drilling for wind farms, metro lines, declines, tailing points, processing plants, and the highest percentage, 33% for deep mining shafts. In underground diamond drilling, we carry out the largest percentage of exploration work for lead and zinc deposits. Another equally important service as exploratory drilling is service for design and research in the field of mineral resources, hydrogeology, and geotechnics. Among the most significant projects that we have done in the last period in the field of environmental protection and renewable energy sources are geotechnical studies for 2 wind farms, Crni Vrh and Krivača, and also geotechnical study on the condition for the construction wasteland fields of the Kolubara region. The location of this landfill is part of the open pit Tamnava West field, where the exploitation of the coal seams has been completed. With the arrived the company ZG Serbia, we got the clients who recognized us as a reliable partner, so we carry out geotechnical research project for Saraka landfill, for Veliki Krivelj flotation landfill, and a geotechnical study for a new processing plant in Majdanpek, all for open pit mines owned by them. For underground mines, geotechnical research projects for deep shaft at the Borska Reka and Čukaro Peki mine were carried out also. Our project team is ready to design, implement, and execute greenfields and brownfields project, a research program, in accordance with procedure and international standards. And in field of geology, Galen Group has relevant experience in design, construction, and equipment for exploration and exploitation wells for multi-purpose use, such as water supply, drainage, sports and recreation, and hydrogeothermal energy. In this short movie, you can see our team out in the field, and I hope you will enjoy. the end, Europe and the world must accept sustainable mining because mining is the basis of the development of society. Thank you very much for your attention.
Dragana, thank you very much for a very good presentation about your company. It's definitely the best point of contact for newcomers to Balkans. Thank you very much. And our next presenter is Dr. Ibrahim Milushi, Head of Department of Geology, Institute of Geoscience, Polytechnic University of Tirana. And the topic of presentation is Structural Studies, the key to success for exploration of the chromite ore. You're welcome.
Thank you very much. Good afternoon to all of you. First of all, I'd like to congratulate the organizers of this very nice event, which brought together participants from 27 countries, and to join our efforts to improve the mining in the future. I'd like to present, as the moderator told, people are interested to close mines, whereas geologists are very much interested to study, to explore, to find minerals. So there is a little bit contradiction, but we'll continue to do that. So, as a geologist, I'll present something for the importance of the structural studies for the finding of the chromite ore. The ophiolites, which are the rocks which host the chromite ore, and especially the mantle section of the ophiolites are very widespread in the alpine belt and in the Albania as well. In Albania, ophiolites occupy an area about 4,500 square kilometers, and the mantle part, which can host the chromite, and in fact, which is the chromite is genetically related with this type of rocks, are outcrop in the shape of two belts. Eastern belt and the western belt. As my colleague Professor Goskoli mentioned yesterday, the eastern belt is very interesting for the chromite, whereas the western belt contains some showings, but those are of the aluminum type and very small in size. So here is a lithological map of Albania, and with black squares are shown all the chromite, major chromite deposits in the ophiolites of Albania, and in the right are shown the two ultrabasic belts. Here are given, are summarized some general data on the chromite chromite ore of Albania. I like to mention here that it is interesting that in one of the ultramafic massives, it is discovered one of the biggest deposit of podiform type, in the world, which is Bulchiza deposit, in which are mined out until now about 21 million tons of high-grade ore. Here are summarized some main features of the chromite ore in Albania, and I am not going to deal with specifications here because I don't like to take you much time. What is the focus of this presentation? The focus of this presentation is that the structural studying and careful mapping of the chromite showings is very important to have a success during the exploration of chromite. And to be successful for this, of course, will be studied the relationship of the ore and the host rocks. We have to identify if there is a sharp contact, gradual contact, or irregular contact. Then, very important is determination of the morphology of the ore body or mineralization zone at the outcrop. Very much important is measuring of structural elements in host rocks and the ore, determining if there is a match or not between the structural elements in the ore body and those in the host rock. Based on this, we determine if ore body is concordant, subconcordant, and discordant. And methodology of the exploration of, in this case is different. And then, very important is measuring of faulting, if it is present, and in addition, a measuring of the foliation and lineation in the faults. To later to determine the exploration and the exact position where we have to drill. It is also very important measuring of faulting and structural elements at the fault plane, determining the direction of movement of the blocks relative to each other. Now let us focus to a very important moment, measuring of I forgotten to mention you that the chromites in the ophiolites are of podiform type, which means that are very much, in most of the cases, are very much complicated and is very much difficult to explore and discover chromite deposits. So, measuring of structural elements. I have shown here some different situations and orientations of drilling works to have high efficiency. So, I presented here showing a graph showing striking south-north, and first we measure the dipping and striking of the ore body, and it was in the past. It was the methodology, in general methodology for the exploration, and based on this, they projected the drill holes. We can have the different situations. At the next figure, we have a longitudinal section, case 1, where the dip angle and the plunge fit together. In this case is quite easy to project, and we can based on the size and different characteristics of ore body, we can put the drilling holes. Then we have the case 2. Case 2, which means we have identified the plunging towards the north. In this case, you see where we have to put drilling holes to be successful. Third case, the plunging or lineation is towards the south. And it is quite different with the first case where we have to drill. And the last one, we have the horizontal lineation, and we have to drill only near the surface outcrop. So in between these two, the case 2 and case 3, we have different situations, and we have to be very careful to measure to be successful for the projecting of the drilling holes. Now I bring here some very fast. I bring here some examples. For example, for the Tropoia massive, I brought here 3 examples to see the efficiency of drilling based on the lineation measurement. Here's one example. When we are in the field, we have to determine the foliation plan. And in the foliation plan is reflected everything which has to do with the shape and the development of the ore body. Here we see antinodal, let's say, very much elongated antinodal, which is the lineation. And we see that towards the plunging is the maximum development of the ore body. And we have to be very much careful to put the drill holes in this case. So in a case we have, we make in consideration, we can see that we have three dimensions here. We have the one dimension towards the lineation, which in this case is very much elongated, and another dimension is dipping, which is approximately 10 times smaller than lineation, which means that when we see this situation in the field, we immediately see that the developing of ore body towards the plunging is 10 times more than in the dipping plan.
Sorry, 1 minute.
Sorry?
1 minute left.
Okay, thank you very much. This is an example where we were very successful, and there was outcrop, and you see that the place where we explored. Same thing, another deposit example. And we have many examples here. Here is nodular, and you can see how much is deformed. And many examples here, but I think that it is clear that the structural elements are very important for the exploration and to be successful for the exploration of chromite ore. Thank you very much.
Thank you very much, and I'm very sorry to stop you. I understand that this topic requires much longer presentation, but it's very interesting and it's very helpful.
Thank you very much.
Thank you very much. And our next presenter, Dr. Steil Lumov, Associated Professor, Mining and Geology, University of Sofia. And topic is the new approach in ore-body exploration, the key to increase the geodata quality and reduce drilling expenses. You're welcome.
Thank you, Andrea. Thank you to the organizers for the event. It's a nice forum to talk about investment, about money, about geology, about exploration. Thank you to Dragan and the colleagues from the Albania. They did a very nice introduction to the things I'm going to talk about. This is the outline of my presentation. My name is Shteryu Ramov. Hello to everybody. I'm lecturer at the University of Mining and Geology in Sofia. I'm also founder of a small company which is called BG Drilling Solutions. We do provide directional drilling services. And it's a pleasure for me to talk about the directional drilling. It's a new approach. Why? Because all the issues we've been discussing here today regarding the mining, exploration, environment, dependencies between mining and the environment, society, expertise, they are related on the bottom line with the work we do on the field. We drill boreholes, we do mining, and everything is related to the nature. We want to preserve it, and this is one of the reasons we have to focus on the technologies which are efficient and help us to preserve the nature in the same time to have the raw materials we need for development. A couple of questions to our audience while you are attending this presentation, to share experience, to learn, both of the above. Your experience on directional drilling, maybe you don't have, or you have some painful experience with directional drilling. What is the great need for directional drilling? And here comes the very, very important question about the quality of the geological data. And the colleagues here they presented, they gave a really very good example of the quality of the data we get. Also, I want to thank Dragana. In his presentation, she showed a nice video about the drilling. What are the quality of the data we need for mining planning, for productivity, for performance, to optimize our program and to save our expenses on the bottom line. So this is very important when we approach the exploration. So what are the issues with the directional drilling or the drilling at all? The quality of the data. First, we have trivial issues like a core recovery, like a foliation, like a dipping, core recovery, a reference depth we get from the core, washouts, oriented core. Just to get all this data we need for planning, we need to know the ore body, the geometry, the concentration of the minerals we need for production. And this is the first group of the issues. The second group concerning the geological data, it's the natural deviation. And very often when we want to drill a borehole and to reach a target, by different reasons, we can't do it. Three main reasons determine the borehole deviation. The first one is related to the geology and the geotechnical parameters of the rocks we drill. The second group of factors, this is the equipment we use, technical reasons. And the third one is the technology, how we in fact drill the boreholes. So on the bottom line, what we spend as a time, as money, comes the efficiency of our drilling program and our exploration program. What is the reason we should use the directional drilling? On the first hand, the precise navigation and reaching the target. If we drill just a borehole for boreholes, no sense. we need to get information. We need to get information exactly from the spot where the geologists expect to get the valuable core, analyze it, and make the further plan for exploration. On the second hand, no loss or repeated boreholes. If the borehole deviates and it goes to places we don't need this information, we have to drill a new borehole. Less sites necessary for prospecting. For instance, to make exploration of area, you have to make roads, you have to build drill sites, and then from those drill sites you have to drill and to get the information. So using directional drilling, we reduce the need for all those drill sites. Of course, this has a less impact on the environment. We have less footprint, and then we save the nature. Of course, it's the directional drilling resolve problems with difficult to assess areas. For instance, we had a project in Peru. It was in Santander mine, which is 4,500 meters over the sea level in a deep valley where building drill sites, it's difficult. So then we can use one drill site, and from there we can drill a couple of boreholes reaching different zones in the ore body. And then on the other hand, we have reduced the volume of drilling meters. Instead of using a drilling program with 10,000, we can reduce it and use, for instance, 7,000, and then the expenses are less. On the bottom line, we have better quality of the geological data we obtain by using directional drilling. In fact, what is the new approach in exploration? There is two options in this new approach. The first one is when we use a mono borehole, and then we navigate this borehole to reach exactly the place we want to get information. This is the first option of the new approach. While the second option of the approach is to use a multilateral boreholes, for instance, to drill one mother borehole, and from this borehole to make a couple of branches, just making penetration in different zones where the geologists really need information. So I have examples for both cases later in the presentation. What we should consider when we decide to use a directional drilling. On the first hand, the depth of the borehole is important. Of course, if we drill boreholes with depth, let's say 100 meters, maybe it's easier, cheaper to drill 2, 3, 4 boreholes. But if we need to navigate the boreholes, then the directional drilling is a need. Next, important is to consider the borehole profile. Should we use a mono borehole or should we use a multilateral boreholes? Next is the intensity of the borehole deviation, because when we're drilling boreholes, we cannot make it as a macaroni. So the dog-leg derivative or DLS, it's an important parameter to decide the directional drilling. And of course, the kickoff point, it's the depth where we deviate the boreholes in order to make the penetration or space between the penetration of the borehole we are planning. Of course, I should make a small review of the available technologies used for directional drilling. The very old one is the wedges. It's a well-known technology. It's used for single deviation. Maybe it could be used for couple of deviation, but making directional drilling with wedges, it's too old, it's time consuming, it's not efficient technology. Next is the deflecting tools. Usually those deflecting tools are used to deviate the boreholes when you have fish in the borehole, when you have some problems and you cannot continue the old borehole. The three modern methods used in directional drilling, it's directional core barrels, it's bottom hole motors, and of course continuum wedging tools. It's a new type of technology which is used in directional drilling. The last three are shown on the left side of the slide. Something which is special for those technologies, that downhole motors and continuous wedging tool, they are full hole, so you cannot get a core using this technology, or steerable core barrels, they get core while you do the deviation. What are the important tasks you have to consider when you decide to go for directional drilling? In fact, many geologists think that the directional drilling is so simple that we can deviate the boreholes as much as we want and we can reach a zone which we want to reach, but it's not the case. Of course, we have to define first the project assignment. It's a very important part of the decision to go for directional drilling. Planning is crucially important. Of course, we plan the borehole path, we do this pre-planning, and then we discuss and decide which scenario we can use for our special needs in this ore body or in this exploration program. Next important part of the directional drilling job is to analyze and borehole path and to control the deviation, because it's very easy to have a perfect plan, but without control of the deviation of the borehole during drilling, you may fail in the end results. And of course, this includes controlling the drilling parameters and the BHA, the bottom hole assembly. Usually drillers, they are interested to drill, to have a meter and meter and meter drilled. But using this approach can compromise the overall directional drilling project. So this is also a very important task in completing successfully the directional drilling project. I'll give you a couple of examples. The first one is for mono borehole navigation. It's actually a project which was related to drilling 4 boreholes with a very strong or very stringent requirements regarding the verticality. The envelope was 3 foot or about 1 meter radius. We had to drill 4 boreholes. And for those boreholes, it's used 45 days. 2,200 meters was the overall metric of the program. During the execution of the program, 130 gyro runs were run, 20 interventions for correcting the borehole path, and then 20 orientation. The next slide shows a picture of, or planned picture of the 4 boreholes. And here you can see on the upper side, we did 4 correction of the borehole, and then starting from the center, 1, 2, 3, 4, just to get the borehole within this strict radius of 1 meter. The next example is regarding the multilateral drilling. Actually, it was planned 1 borehole with 4 branches. The mother borehole was drilled with 8 cuts to correct the borehole to reach the target. And then the first branch hole used a steel wedge, which was set on 1,050 meters depth, and then with 3 cuts, the borehole reached the targets. The second branch was cut, the deviation was made with a continuous wedging tool, and then the borehole went straight to the targets. The third branch was deviated by using a steel wedge set in 888 meters, and then 7 consecutive cuts to get the target. The 4th branch was cut in 1,134 meters, but there was some problem with the borehole walls. There was some flooding and then problems, and so this borehole was abandoned. And the branch 5, the wedge was set a little bit above 1,070 meters and successfully drilled to the target. So on the next slide, you can see plan view and also cross-section of the borehole, which was drilled. For reaching all those targets, you can see target 1, 2, 3, 4, 5 target, 6 target was reached by using this borehole. 1 mother borehole with 4 or 5 branches. So in conclusion, I have listed the most important conclusions regarding the directional drilling. There is a 2 option applying directional drilling, mono borehole navigation or multilateral borehole steering. Second is directional drilling technology is very important in deep ore body exploration because usually those boreholes are expensive. For instance, we drill in Canada boreholes which are more than 2,500 meters. We deviate the boreholes in this depth. All right. The third one, very important conclusion, is that selecting a directional drilling method depending on the needs. Should it be core or should it be coreless? Because usually when we want to make a couple of penetration, we have to deviate the boreholes above the ore body. Then we really maybe don't need the core. So we can use the coreless technology and make the penetration in the ore body spaced in 20, 30, or 40, or 50 meters, depending on the geology of the ore body. And then, of course, the future of directional drilling gets more and more bright compared to conventional drilling, because just drilling for drilling, it's no sense. The geology, they need really quality information to make their evaluation, to see the ore body, the spacing and the geometry and everything related, the foliation and everything the colleagues were talking about. Okay, thank you, that was all. And here, of course, a couple of takeaway questions about the current situation and why we need directional drilling. Of course, yes or no, it's lower the cost, it's save money, it save time. So the drilling, the directional drilling is the future of the exploration of ore bodies. Thank you for your attention.
Thank you very much for presenting a really very good and useful exploration tool. And as you mentioned yourself, it's a tool to collect the information which was already mentioned, structural data. Thank you very much.
Welcome.
And our next presenter, Alexander Prihodko. He is Chief Geophysicist of Expert Geophysics. And his topic is Mineral Exploration Case Studies with Airborne Electromagnetic Natural Fields. You are welcome, Alexander.
Thank you, Alexander, for introduction. Many thanks to MINEX team for gathering us together and for the great job as usual. Hello everyone. Before drilling and before great estimations, before extraction, before problems with tailings, we need to find something. I'm here today to show you some exploration case studies with airborne geophysical technology exploiting natural electromagnetic fields. I will start the presentation with a brief description of the existing currently airborne electromagnetic principles. Then we will describe natural field or passive principle in more details, and will demonstrate several field examples from different regions applied to different commodities. Most of the examples are selected with the possibility of comparison with known geological structures and mineralization or targets. The airborne electromagnetic methods are inductive methods. It means there are transmitting or primary field which energizes the geological environment and measured secondary field or response from the subsurface. The four airborne electromagnetic principles presented on this slide. The VLF principle, its airborne modification is used for about 50 years. It's a very shallow method, utilizes distant radio stations as a source of primary field. The frequency domain method or phase component method with a controlled primary field source have been used as well for many decades. Time domain systems excited by a step pulse have replaced frequency domain systems for the majority of exploration applications due to a greater depth of investigation. in general. However, several limitations restrict the use of the time domain principle in many circumstances. The passive methods exploiting natural electromagnetic fields are the most depth penetrating among all airborne electromagnetic principles, but it's not only one advantage. In contrast to other airborne EM systems, passive technology uses natural electromagnetic fields to investigate the electrical conductivity of the geological subsurface. The passive systems don't use any artificially driven generator or transmitter, which first of all creates noise, and secondly, it's very limited by energy in airborne modifications. Lightning events and thunderstorms activity worldwide cause natural variations of the Earth's magnetic field, including electric or telluric currents. The natural phenomenon creates strong EM source signals over the audio frequency band, which we measured. Similar to the ground magnetotelluric method, we transfer measured magnetic and electric variations into admittance parameters and ultimately calculate apparent conductivities for different frequencies. After that, we invert the apparent conductivities and frequencies into resistivity depth images. In all slides and all examples, you will see the conductive zones or low resistivity zones are in red colors, and highly resistive zones, it's in blue colors. Let's start from the Athabasca Basin in Canada. This is an example from the Share Creek deposit related to the unconformity contact between the crystalline basement and overlaid Athabasca Basin sandstones. We can see the horizontal contact between the main geological units on the depth around 700 meters. And at the same time, we can see the complex morphologies of the conductors inside of the basement rocks. In addition, zooming into the high resistivity sandstone layer, we can see the alteration zone that is imaged in the highest frequencies. This example demonstrates the sensitivity of the natural field system, not only to highly conductive graphitic rocks. Actually, uranium is related to the graphitic mineralization here in the basement, but also to resistivity differences in thousands of ohms related to alteration zones in sandstones. This example is from the edge of the Athabasca Basin, where no overlaying sandstones and with steeply deepened tabular and lenses along specific structures and shear zones in the crystalline basement. The structures are well recovered from mobile MT data up to 2.5 kilometer depths. The next case is from southern Tian Shan structure. The structure hosts a number of important and giant gold deposits, including Contour, Muruntau, Jarmatan, Kakpitas, and some other. The orogenic gold on the mesozonal intrusive related mineralization level occurs where the Vendian sediments have been hydrothermally altered and mineralized. The type of deposit is related to reduced intrusions, what we can see in the resistivity sections derived from mobile MT data. What is important here is depth of investigation. The controlling mineralization structures are observed underneath the conductive overburden with thickness of 300 to 400 meters. In this region, open pit mining is used, but from the point of view of exploration, it's very important to see deeper. It is how the contour deposit looks on the plan map. The low resistivity zone on the depth level is reflecting altered Vendian sedimentary rocks that extend over all the belt from southwest to northeast, according to the deep structure recovered under the conductive metasediments. The Thor project area, it's in southeastern British Columbia in Canada, includes several mineralized zones discovered more than 120 years ago. Some of them were historically mined and some recently discovered, even in this year. The occurrences and deposits are outlined on the maps. The known deposits are following conductive structures, and some of them coincide with discrete conductive zones. There is a new, highly prospective conductive zone here detected on the survey block as well. Anyway, let's look in details to some historically known epithermal deposits on the property. These are places with known epithermal deposits. The 44 lower deposit and recently discovered Thunder Zone. Geologists noted the rocks overlying the epithermal zones usually are incredibly silicified. In the resistivity sections, you can see the highly resistive zones overlying conductive dome structures where the epithermal deposits are located. This example from northwestern British Columbia with the prospective gold zone. The discovered gold mineralization is hosted within iron carbonate altered volcanic rocks. The low frequency apparent conductivity distribution related to deep horizons has very strong correlation with geochem gold anomalies in the area. On the right slide is a resistivity depth section along a survey line. It's a white line on the maps, with the location of gold discovery in an outcrop on the surface and in the drill hole. Because of the depth of investigation of the natural electromagnetic field principle, it is possible to recover the deep-seated mineralization controlling structure here. The Kainantu gold prospect is situated within New Guinea Trust Belt. The structure contains high mineralization of gold, silver, and copper. The sulfide vein deposit is here. Is the most advanced project at the Kainantu area with current defined resources and mining activity in the area. The resistivity section along the white line crossing the known vein deposit is below the conductivity map. And this is a known cobalt, copper, gold occurrence, Thomas Creek in Tasmania, previously investigated by the ground IP, induced polarization method, and the downhole EM. And the natural field airborne electromagnetic method here has recovered different types of conductors, both deep and near surface, conductive overburden, surface layer, and structural conductor, and the discrete body of massive sulfides. The KL1 kimberlite pipe, it's in northeastern Ontario, is known kimberlite, was discovered in 2004. From the results of drilling, the kimberlite is known to be covered by approximately from 1 to 4 meters thickness of glacier overburden, and it's deeply weathered. The bedrock geology consists of Paleoproterozoic rocks. The location of the kimberlite is clearly evidenced by the apparent conductivity profiles or gridded data in the wide range of frequencies, but mostly on high frequencies, because the target is near surface. This example demonstrates capabilities of the natural EM method to detect and recover near-surface targets as well, if the data includes measurement of high frequencies. So we can conclude the electromagnetic principle exploiting natural field as a source of primary transmitting force provides capability of deep exploration of the geological environment and from the surface actually, sensitive in the broad range of resistivity differentiations and much less dependent on terrain clearance comparing to systems with controlling field sources. As practice shows, at a combination of technical solutions, airborne EM systems based on natural fields are capable to solve exploration tasks in wide range of commodities in different geological terrains and geoelectrical conditions. Thank you for your attention.
Alexander, thank you very much for giving detailed information on possibilities of geophysical services, particularly in early stage of exploration. Thank you very much.
Thank you.
And our next presenter is Thomas Paratelli, who is representing Micromine, and the topic of presentation, Future Mine Modeling with Micromine.
Sorry.
You are welcome.
Sorry, let's go back to the start. Okay, thank you guys. Thank you for inviting me, and it's great to be here in person. Thank you to Arthur and his team for the organisation. We've had a fantastic conference and we've really enjoyed it. So again, my name's Tom Paratelli and I'm going to be talking about future mine modelling in Micromine. So let's talk a little bit about Micromine and what we offer. Again, we're a technology provider. We provide software to the mining industry and we're present within all major mining jurisdictions, ranging, and just some facts about the different commodities we cover, from precious metals all the way up to sort of base metals, diamonds and energy minerals. We are present within all the major mining jurisdictions in the world, and we're very pleased and happy to be here in Albania today supporting our clients within the region. So let me give you a quick overview to Micromine, the products and the services that we offer as a company. We've recently just gone out under a bit of a rebranding. The flagship Micromine product has become a product known as Micromine Origin and Beyond to denote the fact that we do kind of beyond sort of resource estimation. Our flagship Micromine product still exists as Micromine Origin. Again, for anyone unfamiliar with us, that is geological modelling, block modelling, mine design, mine scheduling, and we are increasing as a family and increasing as an offering. So we have, and we're supported by the Micromine Geobank and Geobank Mobile for sample management and sample tracking and in-field logging. We've recently brought out a brand new product called Micromine Nexus. The whole idea behind Micromine Nexus is all about the integration of cloud technologies to make much more dynamic and collaborative working environments. We have our Micromine Beyond product that manages everything kind of beyond, and that's what the reference is there, beyond the resource estimation. So it's pit optimization, pit design, mine scheduling. We also have recently acquired two specific and dedicated scheduling companies. So we have Micromine Elastri and Micromine Spry, which aim to bolster our presence within the open pit and underground scheduling environment. And that's all complemented by our Micromine PitRam product, which is real-time fleet management mine control system. So what I really wanted to talk to you guys today about is kind of the mining technology problems, talk about the issues that we're solving with our products, and kind of register what the main problems our clients experience and kind of how we're sort of solving them. So Mining tends to be a bit of a silo, and particularly technology tends to be a bit, particularly at mines and exploration sites, tends to be a bit of a snapshot of the product of its creation. Much like the kind of audio system in a car, very few managers or very few bosses are willing to forgo production to implement new technologies and new systems to change and innovate. So unfortunately, mines tend to be kind of a snapshot of their creation, and that shouldn't be the case. We should be dynamic, and we should always be having a look and open to new technologies. Unfortunately, and I've seen it myself, I've seen it being on client sites, very much technology is out there and technology is available, but people and many sites still do manual hand-based loggings with paper sheets and stuff like that, and the amount of clients that are still using Excel as a database is very prevalent within our industry. So kind of as a technology provider, we're very passionate about kind of integrating the latest technologies and better workflows to improve the ultimate life cycle. Again, IT and technology tends to be a bit of a buzzword, and we do have a lot of clients that, and we're particularly bad at this as an industry, will ban the big words of digital twins around, we'll ban the big word of IT of things, AI, but not actually integrate them properly into our technologies. It's very nice and easy to have one sample site showing you some great technology, but we're really interested about bringing up the kind of the baseline of the technology and the adoption within in the industry. Gartner, the professional services industry, it was quoted in 2020 as saying 80% of AI projects will remain alchemy, created and run by the wizards that created their inception, but will never actually see the light of day. So that's kind of 80% of projects that never actually integrated into actually seeing real world technologies. So let's again sort of continue qualifying the problem and register how to solve it. It's not just enough to collect the data, and kind of that's the important thing here. You can collect the data, but we need to be able to make meaningful decisions from the data. And often our clients have this perfect storm of either not enough or too much data. And sort of hoarding it. Is it in the right place? Is it being actioned by the right person or the right team? So kind of where we sit and where we hope to offer a solution is to be able to provide interpretation and be able to action sort of results based on sort of data. So again, another underlying theme here is what is Micromine doing to help the mining sector's digital transformation? Now, I've given this talk kind of across the years, and the last time I gave it in a conference in Poland, it was mining 4.0 technologies. So here today, it's mining 5.0 technologies. So it's constantly evolving and constantly keeping up. What I want to showcase today is what we're doing recently in Micromine, how we've integrated new technologies and how we're improving the product to benefit our users and to make sure we're integrating the latest technology. So I've got a couple of videos I want to show you. The first video is looking at our Micromine Origin product, and it's about a new product called the Geology Modeler. The Geology Modeler is kind of the next evolution in our implicit modeling offering. We've had implicit modeling really for over 8 years, since 2018. It's a technology we're really passionate about. It's kind of very much proven in industry at the moment. The results speak for themselves, but it's a technology that we're constantly evolving and constantly improving with, and the Geology Modeler is kind of the next evolution in our step to offering implicit modeling technology. So let's have a look at the video, and I'll talk a little bit later. So that was a very quick demonstration of the micromine geology modeler. Again, it is kind of the next evolution in terms of our implicit modeling offering, and instead of just modeling one specific vein or one ore type deposit, it looks at a more holistic approach, and you provide it in much more of a geological order. Instead of just providing units or providing codes and having to figure out the order yourself, you provide the geological information, and the micromine solves the model and solves the solution for you. Kind of the benefit here to the user is that you're spending a lot less time trying to pretend that you know the coding or trying to know the configuration in the background or putting a format that it's acceptable to micromine, and spending more time thinking about the geological interpretations. The speed and the benefit of the implicit modeler means that we don't have to just have a look at one scenario-based modeling. We very much can start having a look at multi-scenario based modeling instead of just very quickly trying to produce a model and get it out and get it produced as quickly. So that was kind of the geology modeler. There was a couple of other technologies in there. There's point clouds that we're really happy and we're really integrating with our new technologies and some other features. What I also want to talk about is the micromine PitRAM offering and how we're recently integrated AI technologies into our micromine PitRAM vision, which allows our trucks and our fleet management systems underground to automatically register the status of the cab. Let's have a quick look at the video. So that was the micromine PitRAM vision product, and it's just allowing, with the use of artificial intelligence, allowing our statuses to instantly updated instead of having to, based on the users or based on the operators, to have to go in and change that schedule. So it's just adding another layer to the product that just enables sort of seamless integration. Again, there's kind of a lot of other new technology that we're integrating within micromine. I'd love to be able to talk to you all day about it, but let's just talk about where we're kind of going as a company. Again, we do 2 yearly releases, and it's all about the development within micromine. We're making sure that we're integrating the latest technologies and making sure that we provide them and roll them out to the users as and when we can. So we're doing a lot more with less. One of the kind of the underlying themes and what we kind of feel that separates micromine out is the fact of the user experience, being able to very effectively and easily be able to manage and make interpretations with the data is kind of what we think sets us apart.
Sorry, time coming, 1 minute.
1 minute, okay. So again, it's technologies to allowing us to do more. It's essential not to just have the data or being able to see the data, it's being able to make accurate interpretations and do so in a timely manner. What's to come? Further machine learning, further integrations. We've got some great products running at the moment about the use of artificial intelligence with the block modeling process. It's really exciting at the moment. Just really the takeaway message. Being able to extract value and understanding from data sources is key to generating value. Micromine integrates the latest technologies, and hopefully I've been able to show you that to facilitate interpretation. The future mine modeling program is really kind of integral to our future, and it's kind of what we're all about here at Micromine. The team is very well present here, so please, if you're interested in anything in terms of mine modeling, mine design or fleet management, please do come and have a chat. Thank you, guys.
Thomas, thank you very much for telling us all about Micromine. It's definitely a very useful tool, and These days, no one can do anything without it. Thank you. And next presenter is Alexander Mikhailov. It's me. Hello. Okay. Nice to meet you. And it's really nice to meet you, and especially everybody saying that it's nice to meet so many people after 2 years of being in lockdown. To be honest, I'm spending my time in field, so it's nice to meet so many people at once. Usually I'm talking to myself. So my presentation is a philosophy of prospecting. Keep it simple. And I'm director of Mineral Exploration Network. Our company is registered in UK, carrying out early stage exploration in Finland and Spain. We started our operation in 2009. We prospected over 5,000 square kilometers and collected more than 500,000 samples. So I'm going to tell you why we are doing this and how we can do it quickly. And I would like to start presentation from quotation from previous session yesterday. Without undertaking its own exploration, the EU will have no new mining projects. And European continent remains underexplored in terms of greenfield resources. And below you can see pyramid. So if you would like to open new mine, we need to have from 500 to 1,000 new prospecting projects. It means that if we don't have 500, 1,000 prospecting projects now, in 10 years we will not have new mine. We will be just scrapping what we have already. Looking on it from different perspective, what ground do we need to prospect? So to find one mine, we need to prospect about 4,000 square kilometers to find one mine. And budget from stage to stage rocketing. So when we are doing prospecting, we have huge ground and we have very limited funding. Yes, of course, some multinational big companies, they can come to Alexander and ask him, could you fly for me 1,000 square kilometers? But we are a small company, we have limited budget. What should we do? Just one. Yeah, and yes, one directional hole, but where? So, and looking on different approach to prospecting and exploration. So prospecting, we have huge ground, we have limited budget. And prospecting, the task of prospecting, we need to explore that ground quickly, cost effective, and results should be just good enough. We don't need to have that precise measurements, precise data as we need for resource and results. So just repeat. Prospecting should be done just good enough to identify area where mineralization could be found. So, and what method could we use? There was very good publications in 2014, critical analysis of successful gold exploration methods. And us analyzed discoveries for last 10 years, and they came to conclusion that surface and near-surface sampling dominate early phase of exploration discoveries. When alteration mapping and structures, they support, but they are not leading. So, and there is very simple example. Let's say exploration in Finland. What kind of structural measurements at early stage and alteration mapping can I do in this swampy forest? But if I will come with soil sampling, let's look on left diagram. That area, about 80 square kilometers, was prospected in less than 1 week by 2 teams. And it's delineated immediately area of interest. And then it took us just 2 weeks to do detailed geological sampling. Yes, it's example from Finland, where is no outcrops and no information available for structures. And there is example from Spain. Nice area, you can see subcropping rocks, hilly area. You think that you can find everything just walking around. But this area was known from mid of 19th century. It was biggest phosphate mine in Europe. And this geological map, it did not change in the last 200 years. You can see all structures which are mapped now. They were mapped in 1947. And if you look on that black square, it was area where more or less modern exploration were done in 1982. geological survey mapped did detailed mapping, traced the structure, put the trenches, and did not find anything. Later, we did soil sampling, and you can see there was industrial grade, tungsten industrial grade in soil, but it was not found, even in nice environment with good outcrops. And when we trenched it, we had found that mineralization was sitting 18 meters from the quartz vein. So when previous explorers, they were tracing quartz vein, but they did not knew that mineralization sitting on 2 meters of soil, and it's really good mineralization. I'm not saying that, to be honest, that exploration was done in 1982. When I look on the report, it was done in time when I was just graduated. When I look on the report, I would not imagine to do better jobs as I did. But that time, they did not have that technical abilities which we have now. So, and of course, yeah, we are talking about green exploration. This trench does not look green, but we closed it the same day, and 1 year later, you could not see it. And we start using, from the point of view of speeding up exploration, we did not dig any single trench after this. We were just using rotary blast drill rigs. And it's appeared cheaper, faster, and providing better information than trenching. But coming back to sampling, quantity of samples transfer to quality of exploration program. The more samples you have, the better picture you have. But it's, and of course you need highly productive and cost-effective analytical method. It may be sounding contradicting that I'm saying prospectors usually have low budget and taking more samples will be more expensive, but it's not true. You can take more samples without increasing expenses. Just reduce size of samples and take it quick. There is example on the left. There is detailed soil sampling, and on the right, traditional soil sampling. In both cases, it took the same, the traditional sampling. When traditional sampling was done, one team, 3 teams in field were able to take 200 samples in a day. When we were taking smaller samples and shallow samples, one team could take 200 samples. So speed of sampling is about 3 times more. And cost of sampling is the same. But then, of course, it's about 3 times more assays. What to do? And of course, there is magic tool, portable XRF. When you are using portable XRF, your mind is changing. Because when you are sending samples to external lab, every sample you take, you think, it will cost me so much, and I have limited budget. If you have portable XRF, you do not bother about the amount of samples. Even more, if you do not analyze samples which you can analyze in that day, you have wasted your money. Why, what for did you bought portable XRF? It should work 24 hours. So you easily can analyze 1,000 samples, more than 1,000 samples a day. The only problem that you need to keep at least 2 operators to analyze this amount of samples, and its cost. And I prefer to have these operators in field to collect samples than to press button in office. So there is very old and simple solution, just use child labor. And please take it serious, it's not about that issue that child labor is free. If you take lazy boy with good imagination, he will come with good solution. Just take toy robot, portable XRF, connect it with duct tape, and you have automated unit. And if you later take it a bit further, you just develop proper automated unit. And this unit's already used on many companies, and there is Pulsatec from Finland. They bought from us 2 units like this. And now you can really analyze thousands of samples without increasing your budgets. And I would say that if I'm doing prospecting for base metals, I would not send samples to external lab because XRF is good enough. I will send control samples, but it will be just, what, 3–5% of amount of samples. But nothing perfect in this world. XRF could not analyze gold, could not analyze platinum, rare earth metals. But there is easy solution as well. So now let's look on this video.
Multi-element fine fraction analysis, or MEFA, is cost-effective methodology for soil and stream sediment sampling. First of all, we reduce the size of samples to 30 to 50 grams and increase the number of samples. Analyzing samples with portable XRF without drying and sieving significantly reduces time without losing overall efficiency of geochemical survey. But gold and other precious metals could not be analyzed by XRF and require separate assays that are not cheap. Therefore, we developed MEFA. MEFA sample preparation is very simple and could be organized anywhere. Extraction of fine fraction by separating particles in water allow us to avoid nugget distribution of gold. And we can dramatically reduce the size of samples and amount of analyzing material. Weight of 100 samples ready for assays is only 800 grams. Thousands of samples could be sent to the laboratory from anywhere in the world, quick and at low cost. Analysis of gold grade, or any other precious metal, carried out by complex of laser ablation and mass spectrometer. Analyzing material without chemical dissolution dramatically reduces the cost. Highly sensitive mass spectrometer allow analysis of gold grade at sub-part per billion level. Multi-element fine fraction analysis is a cost-effective alternative to traditional analytical methods used for soil and stream sediment samples. MEFA. Keep it simple.
In this video, we are talking about gold. It's just because most of our targets were gold. But mass spectrometer can analyze everything. Rare earth, platinum group, everything what you need, you can get very good results. And there is comparison of multi-element fine fraction analysis with traditional samples. I especially picked up results which were given to us by Eldorado when it was working in Serbia. You can see that multi-element fine fraction analysis giving more contrast, clear anomalies. And if we compare MEFA with MMI, we have the same picture. So we already did hundreds of thousands of analyses, and I can tell that MEFA results are compatible or better to traditional methods. But good thing that you can take more samples quicker and to get better results for the same money. So it may sound like cheap advertisement, but it's true. And of course, it may be sound that I'm fooling sampling and I'm forgetting everything else. We do geophysics. And again, geophysics should be quick and at high level. So thank you very much. And from my point of view, secret of prospecting is keep it simple and keep it sampling. Thank you.